Watch this video for an introduction to distributions of data, a critical mathematical principle for performance testers. Understanding how your performance test results data is distributed is necessary to determine what statistical methods are appropriate to apply to that data. Uniform distributions and normal distributions are the most commonly found distributions in performance results data. Statistical significance is a measure of how well your data conforms to a particular distribution, such as a normal distribution. Rarely occurring individual data points that don't conform with the distribution of the rest of your data, known as outliers, may sometimes be excluded from summary statistics without inadvertently impacting the meaning of your data. Here we see a graphical depiction of a uniform or linear distribution. With a linear distribution, each data value occurs roughly the same number of times as every other data value. Notice in this graph that the time measurements are rounded to the nearest whole unit. With a linear distribution, given enough data points, the distribution should remain the same regardless of whether you round to the nearest whole unit, half unit, tenth of a unit, etc., so long as you use the same rounding rules for the entire data set. Here we see a normal distribution, also known as a bell curve. Most measurements of human activity turn out to be distributed normally. For instance, think times are often distributed normally. The most critical aspect of normal distribution is that the frequency of occurrence of results is heavily weighted towards the center of the data set. When conducting performance testing, one rarely has enough data to calculate statistical significance mathematically. One alternative is to plot the range and summary statistic of interest of several tests on a graph and determine the significance visually based on whether the plotted tests appear to be similar to one another. The graph on this slide shows that tests 1, 2, 4, and 5 are likely statistically significant in comparison to one another. However, this chart shows that test 3 was in some way statistically different than the other 4 tests. In this case, it is up to you to decide whether there is an anomaly with test 3, or whether more testing must be conducted to determine the reliability of your results data. Statistical outliers are single rare data points that don't conform to the distribution of the rest of your data. In general, to be considered outliers, the data points in question must account for less than 1% of the total data collected, be significantly anomalous from the rest of the distribution, and not be repeated exactly in multiple test runs. A data point that meets these criteria is statistically acceptable for elimination from the summary statistics. This video has given you a brief introduction to two types of data distributions: an expedient graphical method to approximate the degree to which the data conforms to a particular distribution, and a simple way to determine whether or not a data point that seems to be out of place may be treated as a statistical outlier. For more information about data distributions, see the Performance Testing Guidance Project at codeplex.com. More information on this topic is also available in the Performance Testing Guidance for Web Applications Guide, also located on codeplex.com.